and I did it. I started it up. It's happening.
Can anyone see us and hear
We
us?
require some kind of external validation to know that we exist. Are we
This is
Boltzmann
one of those
brains?
special cases where really someone needs to confirm.
Yeah, exactly.
It's
Yeah.
not our ego, it's our
It's
technology.
literally quantum mechanics at work here. If no one observes us, then we don't exist. Man, this sucks. You're on a computer screen again.
I know. It was so good to get to see you for a few days
Yeah.
and to get to. You are a true extrovert, and I always forget what a power that is until I watch you like talking to this person, talking to that person, and it is a sight to behold, and it was a pleasure to be in your presence.
It was such a. I gotta say that was such a fantastic experience going to ThinkerCon. The part that is amazing was, this part where you're just hanging out with these people. You don't know who they are in many
Right.
cases, and it was very funny to be able hanging out with these people and you're chatting with them. And then we were at the big public conference, and many of these
Getting
people had
mobbed.
gigantic lines for people who were waiting to talk to them, and I didn't even know who they were. It was
Yeah.
it was a funny thing, and you kind of want to sort of. It was great to just to get to know people, and they're all wonderful, and you all have
Yeah.
this great experience with all these people because you have the same problems, right? I mean, not everybody is on an island in Canada dealing with
Right.
dreary winter, but that you're creating content, that you're interacting with fans, that you're trying to figure out how to stand out amongst all the mainstream media that is still casting a long shadow over everything that we do,
Yeah.
and you just talk to these people, and it is kind of great to not know who these people are. So anyway,
Yeah.
uh,
The thing that got me that was so amazing was how many I'm going to call them recovering academics for lack of a better term,
yeah,
people like me who are at that point where they want to keep doing research, but really the whole academic thing, they're trying to figure out how to just add good to the world.
yeah.
And you can't always do that when shackled with academia in its full incarnation.
Yeah, I mean these
And it
were
was inspiring.
largely educators, and for them to, on the one hand, being a researcher having a professional training in one of these scientific fields, and then on the other hand attempting to share this information with other people, it's surprising. That was, you're
Yeah.
exactly right. I don't have this problem. I'm a complete Ronin in this case, but for a lot of those people, they have these institutional connections that they have to satisfy and fulfill at the same time. And yeah, absolutely. Sometimes heartbreaking to hear how much resistance they get from their educational institutions to just help teach people the state of science. It's a funny thing.
Yeah, and it's one of these things that I think the username Krelnick put the best about you several years ago in comparing what you do with what academics do. It was like there was no focus groups, there was no proposals. He didn't ask
Yeah,
if he could, he just did it.
yeah.
And this is one of the things that I've learned to do from you. And I have to admit, I've had my hand slapped more than once over the years.
Sorry.
But but
And
I'm
that's a
working
Canadian sorry. So they're worth
and
double.
and I'm getting myself into a place where that's never going to be a problem again. It just took me a while.
Yeah, exactly. As long as you don't have to rely on anybody else, then you're free and poor. Um, so, um, well, let's get on to this week's episode. I want to say hi to a bunch of people. Hello to Andy Cowley and Colin Jones, Dusty Reichwin, George Edgarog. You're going to have to tell me which one was right. First or second, George. Giselle Sabarin, Guido Bibra, Harry Patrick, Helg Bjorkog, John Suffield, John Victor, Catherine Akonsky, K Spence 303, Richard Hayes, Ronald McCoy, Susie Murph, Tech Tang, Okubil Druin, Zapfan, and I don't see a robotic protector in there, but hopefully Nightbot is in there somewhere as well. He might have gotten disconnected. Oh,
We
Nightbot.
welcome our bot overlords and require their presence.
Yeah. Protect us. and save us a lot of time. All right, so if you're wondering what it is you've stumbled into, this is going to be a live episode of Astronomy Cast. We're going to record episode 507, Ion Engines, which is mind-bending to me that we have not covered this as a topic. Did you search our archive to see if we had covered ion engines?
I did, and
I was
we
like, no
hadn't.
way. Yeah.
And it's like they've come up here or
Yeah.
there, but this is going to be the first in a series of things that started in science fiction, or started in science, got stolen by science fiction, then became reality in science.
Yeah. Yeah. And so same thing. I was like, oh, like you posted it and you're like, oh, we've already covered that, Pamela. And then I looked
No.
and like, nope, brand new. So anyway, and I was thinking maybe next week we do a holiday gift special again. If
Yes. Yeah.
you
Yeah.
want to do that?
Yeah.
Yeah, I've been brainstorming topics, and then I was like, oh, we should cover that. So why don't we? Because I got a bunch of fun things that I want to let people know about. So, thanks, John. I'm glad you're enjoying the book. All right, let's get into the show. I'm going
Okay.
to press record.
I'm pressing record. Hey, Chad. I
Hello,
turned the
Chad.
fish tank off. Be proud of me.
You did it.
I did.
All right, here we
The
go.
small things.
Astronomy Cast, episode 507, Ion Engines. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I have to admit, things are kind of meh right now.
Yeah.
So I have this great brand new job, and it's one of these things where, for years, CosmoQuest, Astronomy Cast, we've been trying to have a major impact while working from small institutions that are more focused on education than research. And it turns out sometimes you're better off when you're with the big publishers at the big research institutions. And so I looked for a job and looked to move my entire program over to the Planetary Science Institute after happily getting hired. And NASA isn't letting us transfer our grant, and is in fact canceling our grant. So no one gets to keep the grant. And Merry Christmas, unless there is a miracle, I have
Yeah.
to fire my entire staff, including myself, because in astronomy, you can have a job and no salary. So yeah, that happened.
Oh, ouch.
So
And of
we're
course, I mean
trying.
this grant. So can you just explain briefly what this grant has been covering and was expected to cover?
So this grant started in 2015. We were one of 31 projects selected when NASA did a massive reorganization, and brought all of their education and citizen science programs together in one portfolio. Since then, we have been working to launch new citizen science projects. This has been funding a whole bunch of student programmers, an early career, not actually a student programmer, myself, and several educators, researchers working on the science all over the nation. So this is a number of scientists, a whole lot of students, a postdoc, all of us, no salary starting January 1. So I know I can get more grant funding. I know I can keep the project going. We've been doing this since 2012. But as we've talked about in past episodes of Astronomy Cast, it takes significant time to apply for new funding. And we'd started to get some hints in August that this might be coming. We were warned that James Webb Space Telescope cost overruns would lead to the cancellation of some projects. And when someone takes the time to tell you that, you know you're in jeopardy. We also were told that there were new policy changes on citizen science coming that may cause funding difficulties as well. But August to now, I've been traveling the whole time. So, yeah, I'm going into overdrive, writing grants, proposals, and begging on the internet, which is why we're bringing this up during this
Yeah.
episode.
Right. Yeah. While
We
Pamela writes all of the new grants proposals to fill in the funding to make sure that all of these projects that we're working on continue along, uh, grant need. I think we require some bridge financing.
Yeah, so I'm trying to raise funding so that I don't have to fire my staff. And I personally, because I have a husband who can pay the bills, I'm only going to pay myself off of any grants that I find. So what we're trying to do is raise money by lifting every rock we can. So we have four specific asks for today. One, go support Patreon. That will keep Susie going, who has a college daughter, that will keep Chad going. Um, Go if you don't want to support us on Patreon, if you just want to do a one-time drop of funding, CosmoQuest X on Twitch is linked to our PayPal account. We are in this weird situation where NASA cut our funds, but we're not allowed to ask for funds on our website. So I'm going to send you to Twitch and donate through Patreon. The third thing you can do is give science for Christmas. You can go to CosmoQuest X's Redbubble store and buy all sorts of amazing artwork by Austin Hinterlander and Chris Spangler. They have done amazing space apparel, phone covers, the whole nine yards. Give everyone you know something like that. And the fourth thing is you can sponsor individual days of 365 days of astronomy. We have links for that as well. And next Tuesday, on Giving Tuesday, I'm going to be sitting on Twitch and recording all of your sponsorship messages. So for $45 a day, if you go to 365 daysofastronomy.org. Look for the tiny words in the right hand sidebar where we've kind of hidden it. You can sponsor a day, use it to promote your organization, commemorate a past loved one, celebrate an anniversary. Dedicate a day to whatever and give me something cool to read. And I'm going to record all of this on Tuesday. So that's it. Those are the things you can do. Please don't
Yeah.
make me fire everyone for Christmas.
Oh, I believe they call it laying off. But yeah, and so I mean, just to be clear, like you don't take a salary from what we do with Astronomy Cast. I don't take a salary. You know, in 13 years, neither of us have taken any money from Astronomy Cast.
We've paid for travel.
We've
paid
right,
for a bunch
of course,
of travel.
but it's the team,
Yeah.
and we want to be able to cover the cost of the people that help us with the projects that we do, and to be able to bring science. So, those of you who can support us, you know, and if you've been sitting on the sidelines, you're like, I kind of like Astronomy Cast, I kind of like what gets done, and I would really like that to continue, and more of that citizen science outreach to be out there in the world. This is the time. We need your help. Please follow some of the instructions. If people want like one place where they can go and sort of see how they can participate, where would you recommend that they go? What's the one place that then will lead them all of the paths?
All of this is going to be up by the end of today on twitch.tv/CosmoQuestX.
Okay, perfect. Then check that out. Before we get into the show, sorry we're using so much time with the not show part. I just want to do a quick shout out. Our good friend Dr. Paul Sutter's book, Your Place, in the Universe, Understanding Our Big Messy Existence, just came out a couple of days ago, and I finally got my copy, and I can't wait to read it. So congratulations, Paul, and of course you can buy that wherever books are sold. All right, let's move on to the show. Here we go. I know I lost my information. Sorry, Chad. Or don't cut it out. Whatever. Okay. Ion engines are a mainstay of science fiction featured in both Star Trek and Wars. But this is a very real technology, successfully used on several missions out there in the solar system right now. How do they work? And what are the limits? Pamela, ion engines. Science fiction?
Yeah, TIE fighters, don't you know? I mean, this was the original ion engine I learned about. It wasn't the original ion drive, but when you see that blue glow on the back of a Star Destroyer, that is all the ionized particles coming out the back engines of this massive destroyer. It's the same kind used on these little tiny fighters, and they have the mass to acceleration ratio totally wrong, but they got the colors right. Maybe, maybe.
They totally look like actual, and that's the part I love about ion
Yeah.
engines when you see them in reality, is they totally look like science fiction. This diffuse blue glow that is streaming out behind the engine system. It's fantastic. And so finally, we've got science fiction is hitting our reality. So what is the underlying science behind ion engines? How do they work?
It is one of those rare cases where the name kind of says it all.
They
You
are
take
engines made
ions.
with ions.
Well, they're engines that move ions. So you have some sort of a electric field or a magnetic field or both that are used to accelerate particles that you have ionized or that the universe is ionized for you. And as you accelerate these particles, you shoot them out the back end of your vehicle. And conservation of momentum, if something goes out the back, the spacecraft has to move towards the front.
Why are ion engines so cool then?
Well, with normal propellant, you can't exactly get that burning hydrogen, that burning, well, it's not burning hydrogen. You can't necessarily get that burning solid rocket fuel going at close to the speed of light as it escapes out the first or second stage of that spacecraft that you're watching take off the planet Earth. And due to the tyranny of the rocket equation, you end up having to have 80 to 90% of your rocket is composed of fuel just to get you off the planet. Now, with ion engines, you can accelerate those ions to close the speed of light. And this means that for a much smaller amount of mass, you can get a much larger, we call it delta V, change in velocity of your spacecraft. So something like the Dawn spacecraft is going to go through ounces of fuel in its ion engine and be able to accomplish 10-kilometer per hour changes in velocity.
I mean, there's two parts to this that are really important. The first one is when you look at the momentum equations, when you consider the when you run your equations with physics, you really have two
Yeah.
things at play. You have mass and you have velocity when you're considering the overall momentum that's coming through. And which of those matters more?
It's really the momentum is a combination of these.
Right, right.
So
But
it
velocity is a big factor.
it's a it's a big factor. And I mean, if I had the ability to hurl microscopic black holes out the back end of a spacecraft, these have massive mass,
Yeah.
but
So,
I probably couldn't hurl them that fast.
right, right.
And so there, the huge amount of mass going at a not very large velocity
Yeah.
would work. But except when you're dealing with like these degenerate matter and black hole matter, uh, mass takes up space. So if you don't want to take up too much space, you really want to go faster.
Right. You want so that's what I was driving at, which is that, if you want to carry a bunch of like if you're going to try to impart momentum to your vehicle, you can either throw heavy objects out the back, which were very expensive to launch from Earth, or
Yeah.
you can throw very light objects out the back of your spacecraft at incredibly fast velocities. So that's the first thing is that you're instead of having to throw big, cinder blocks out the back of your spacecraft to impart velocity, you are to impart momentum and velocity. You are throwing literally individual ions out the back of your spacecraft at, as you say, enormous velocities. But the other
I now
part,
really want to run calculations for an ion drive that uses microscopic black holes that are somehow charged.
or cinder blocks, but sure. Uh, but then the second part to this is the fact that an ion drive can use electricity to accelerate the ions out the back of the engine. And so with a traditional, again, chemical rocket system, you need to have your oxidizer. So you need to carry the fuel, and then you also need to carry the oxidizer for the fuel to be able to to be able to use your chemical engine. And then you don't get a very high, as you said, velocity out the back of the spacecraft. With an ion engine, you use electricity to accelerate them, and so you don't need to carry that oxidizer. And the amounts of fuel that these engines require is tremendously less than a traditional chemical rocket.
Yeah, the trickiest part, at least to me looking at this, is making sure that you don't inadvertently attract yourself back to your fuel. You are shooting ionized particles out the engines, and uh, the way they do this is they excite the particles. Xenon gas is something that's commonly used for like the Dawn spacecraft, and you're stripping the electrons off of the xenon. And they use xenon because it's really easy to strip the electrons off and get a charged particle. But if you don't also shoot the electrons back into the mix as it exits the spacecraft to make that a neutral gas, then you're going to have the charged particles attracting you back to your spacecraft.
Right.
So it's really cool to figure out how they're able to do all of this, take the electrons one way, take the charged particles the other, toss them all out so that they mix together, and off we go.
Yeah, you're getting rid of you are you're taking this plasma, you're stripping off the negative charges, and you're dumping them so that, as you said, you don't, and then you are accelerating these ions out the back of your engine and trying to make the whole thing balance. And the so what's the big downside? Why isn't it all just ion engines all the time?
It's slow. The TIE fighters lied to
Yeah.
us with their twin ion engines. They may be able to zoom around the Millennium Falcon, but let's face it, that universe is bad with their units.
Right.
It turns out that in general, you just can't toss enough particles out fast enough to be able to do anything rapidly. I remember the day that they did the Hasta La Vesta celebration with the Dawn spacecraft leaving Vesta to head off towards Ceres. And they kind of had to estimate when the spacecraft would be leaving because it's such a slow acceleration that they weren't entirely sure when they'd hit escape velocity. It's not like you just turn it on and off you go.
Right.
No, no,
Yeah.
not so.
Yeah, I think it was, and I forget the exact number, and I apologize. It's something like 0 to 60 in weeks,
Yes.
right? So you turn on the engine, and it's been described that you take that the actual force that's coming out from the back of your ion engine is about the same as you take a piece of paper, hold it on your hand, feel the force of gravity of the piece of paper, which you can't. That's the amount of force that's being applied to the back of your entire thousands of kilogram spaceship. And so it is a constant acceleration, but it is incredibly weak. But upside, you can run it for a long time. And that's what they did. And so they'll run these ion engines for days, months, weeks. There's test ion engines here on Earth that have been run for, I believe, years.
And they're starting to develop drones with no moving parts
Yeah.
that use ion drives and ionized air.
Yeah, now there's a bunch of super cool technologies, and you skipped right to the end.
Of course I did.
Yeah, but this came out like 2 days ago, so this is
Yes.
brand new science. Did you read
Yes.
into this at all? Have you learned what's going on here?
Yeah. So it words. Overly excited about this really cool new technology. So it had long been known because of early testing. This is technology that was first prognosticated as well. We should be able to do this all the way back in the early 1900s. And when I say the early 1900s, I'm talking like pre Goddard. This was figured out by a Russian scientist in 1911, Konstantin Tolskovsky, and then Goddard built on what Tolskovsky had predicted. And these two early pioneers of rocketry basically said, okay, so we know that our atmosphere has charged particles in them. What if we set up a ion drive that can accelerate those few charged particles? They're going to hit other particles. They're going to, and this whole process just drives going faster and faster and faster, which is super cool, but wasn't practical because creating the energy field necessary required significant weight until very recently. So they did tests to see if they could drive air using ions. I have to admit, I actually, the first time I saw a Dyson heater, I was like, ooh, I wonder if that's ion air. No, it's not, as near as I can tell.
No, turns out it's not. That it's just a traditional fan in some kind of plastic casing that makes it look like it's doing
I
that.
was so
I
sad.
know, I know.
But so people had been testing ion air accelerators to get air moving without fans and things that can like do harm. Well, it worked, it just required a lot of electricity. Well, nowadays we've figured out how to handle all the parts at a significantly lower energy cost and with significantly less weight, because everything except for the thing making ions is now much more energy efficient, and things like lithium ion batteries significantly lower the weight.
Yeah, and so there have been some tests of an airplane that was flying around, I think at MIT,
Yeah.
um, where there's no moving parts. It's flying around just through electricity ionizing particles in the atmosphere and using those for thrust. Absolutely fascinating. Possibly not practical in any way, shape, or form, that it won't scale up and you can't turn it into anything that will be super useful, but at the same time, possibly uh, the way to make. Oh, you know the thing from the Avengers, the big floating, you know,
Yes.
yeah,
So the thing here is the amount of air thrust that they can create should double if you double the amount of thrusters that you have. But mass in general goes as the cube of the size because of that whole volume problem. So the mass of your drone is growing faster than your thrust is growing. But this starts to get at least people like me thinking about what about combining dirigibles and ion
yeah,
thrusters. You can have completely silent transportation. Now, I admit, I'm pretty sure I'm someday going to like die by electric car because I don't hear them coming. But the idea that we can have drones that don't sound the way quadcopters
yeah.
sound, I if we're gonna have a droney future, I want it to be one filled with ion
Yeah,
drives.
this is a thing that people aren't ready for. Like people think we're gonna have drones, we're gonna fly around in drones, we're all gonna have our personal drone, but these things make a lot of noise, and there
Yes.
is no way under the laws of physics to prevent that noise from happening. And so if you replaced cars with drones, there would just be this racket all the time, everywhere. So yeah, absolutely. Um, uh, so there's a couple of interesting technologies. Have you heard about this idea of an air-breathing ion engine, an ion thruster? So this was a
I
test that was made by the European Space Agency and some groups working with them. And so one of the ideas that they had was instead of taking xenon fuel, putting that on your spacecraft and then using that as your fuel source, which will eventually run out. What they're testing out is can you have a satellite that is flying low enough to the Earth be able to pull in particles from the air and turn those into fuel, turn those into thrust. And they were able to do this. So you can have an ion thruster, a solar powered ion thruster that sits on a satellite that is much lower to the Earth than the International Space Station and other things where they're starting to get buffeted by the atmosphere, but pull in enough particles from the atmosphere to be able to counteract the deceleration into the atmosphere, and essentially station keep itself at a very low altitude forever without any fuel, because it's just pulling in particles from the atmosphere using solar energy to accelerate them and maintain itself. So ion engines are the best.
And when you start thinking about all the ways that you can combine them with hydrogen scoops and other forms of scoop technology for interstellar travel, when you start thinking about combining them with uh, solar sails, we're looking at a very graceful and slow moving spacecraft future where we are able to escape a lot of that, well, rocket equations problem that has killed so many spacecraft we loved.
Yeah. That doesn't help us to get this stuff off the surface of the Earth, though. We're still going to need
Yeah.
those chemical rockets to launch from planet Earth to get, because again, the force from a piece of paper is not going to give you enough thrust to get your spacecraft out into space. But far more powerful ion engines are in development, including a pretty interesting one at NASA. Have you seen their new Hall thruster that they're working on?
No, I've heard that it's coming, but I don't know the latest details.
Yeah, so I mean, it is just like an enormous amount more electricity running through the system, and they're able to get I believe they're able to get it up to 1 Newton.
So that is a unit of force.
Yeah,
1 Newton is the force of
it's like nine
it's
point eight newtons
kilograms
is
meters per second.
yeah.
So it's 1 kilogram. I I
It's
can't.
it's 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 a it's far more. The current ion thrusters are 0.5 newtons. Oh, so I think it's more than that. Um, so they're able to get it up by, I think, by like a factor of 10. Anyway, it's significantly more force coming out of this ion thruster. But the problem is that it's going to require an enormous amount of electricity, more than you can generate with solar panels. So the idea is to match this up with some kind of nuclear fission reactor
And
on.
this gets us right back to Star Wars,
I
where they're
know.
using fusion reactors
Fission, just
to
fission, not
generate.
fusion. Don't be crazy.
Right,
Yeah.
but in Star
Oh, right.
Wars, in Star Wars, they're using fusion reactors to generate charged particles that they're accelerating out of those star destroyers so that they can bring their triangular death upon the universe.
Yeah. Yeah. So you can imagine a future spacecraft is going to be equipped with a NASA built fission reactor that is using that fission power to power high thrust ion engines. You're still not going to be able to launch from, say, Earth or even the moon or Mars, but you could take a much larger spacecraft and do a lot more interesting missions. Do you remember the GMO mission, the Jupiter Icy Moons Orbiter mission? This was a mission that was
No.
planned back, I think, when we started Astronomy Cast, and it would be an orbiter that would visit each of the 4 Galilean moons, and it was going to be equipped with a fission reactor and powering all of these ion engines, and that's the kind of ability to change velocity that you would need to be able to go to all these different worlds. So it got canceled, but
Yeah, this is why spacecraft are dead to me
yeah,
until they launch. Although apparently I'm dead to James Webb Space Telescope's over budget.
yeah. Wah, wah. It'll
Yeah.
launch, and then it'll thank you. But Hayabusa is
Yes.
using an ion engine.
Yes. And this is really the way of asteroid exploration of the future. Just kind of carry on, slow and steady, studying those rocks.
Yeah, and so right now, I mean, let's run through all the missions that are operating with ion engines as we speak.
Oh man.
Hayabusa, there's the Dawn mission. Those are the ones that,
Dawn, rest in peace,
yeah.
has ceased operations and is simply orbiting Ceres without communications at this stage.
Previous to that, there was the European Space Agency. They had their Smart 1 spacecraft, which was
Yes.
able to travel from the Earth to the Moon purely on ion power, very slowly, very carefully. There was the Deep Space One spacecraft, which I think was the first one, and that was really like a test bed of a pile of different
CERT.
technologies.
CERT 1 and 2 in the 1960s, predating Star Wars, were the first
Oh,
applications.
really? Okay, all right,
Yeah.
yeah. So it's a and there's sort of a funny history about the ion engines that led into them using it on the Deep Space One. They had to they were too terrified. NASA was too scared to use a bunch of these technologies for actual missions. So they gathered up like 15 different experimental technologies, put them all on this one mission, Deep Space One, and then just had it test out to prove that all of these were feasible ideas, including ion engines and automated. It had its own way of finding its location in the solar system, and it had a bunch of other technologies on board. So,
R&D money done right.
yeah, I think that's a great way to do it, right? And so, now we really know that these ion engines are so successful. They're just stable, and they push and push and push. And I really hope that we'll see more of them on more. Everything should be equipped with an ion engine all the time.
Yeah. And we're seeing this coming more and more out of Europe, which is what let me rephrase it. We're seeing this more and more coming out of non-NASA. So Bepi Colombo, which launched a few
Right.
weeks ago,
Yeah.
it's another one of these. And the thing about that mission that really gets me is it was named in 1999, which meant that people were like already working on it long enough to know it was going to be a thing when they named it in 1999. It just launched now in 2018, and it's 7 years before it will hit its scientific orbit. And here they are flying with ion drives on a spacecraft that, heck, I had just gotten my master's degree when they finished building this thing, when they started naming this thing.
And of course, being able to go close to the sun to be able to get more solar power to be able to power your ion engines is better.
Yeah.
They don't work so well solar powered if you're going to try and go out to the outer solar system where you don't get a lot of energy. So it's really that sweet spot, a place that you have a lot of electricity and you don't need and you're not trapped in a gravity well. Then ion
Right.
engines make perfect sense all day long. All right, well, thanks, Pamela. We'll see you next
My
week.
pleasure. And Chad will fix that,
Willie, should he?
maybe.
Okay. 507.
Yep.
All right. So what were some ideas that I had? I want to export the WAV file. Hold on. All right. Focus, Fraser. Focus. Okay. Direct imaging of exoplanets would be a cool topic. The
I want to
supermassive.
do more science fiction that became real.
You want to do more of that?
Yeah, we're going to do this
Okay.
for a few weeks.
Okay,
We're
sure.
going to do next week is our holiday guide,
Okay.
but
Um, uh,
yes, that just I want to
supermassive
do more
the
science fiction.
SGRA star
Sag A
specifically,
star?
Sag A star. Like we've talked about supermassive black holes, but we haven't like talked specifically about Sag A star, which I think would be fun.
Okay.
I put in a bunch of missions as well, and then one that I thought would be interesting would be like just how space exploration gets done via the political system that underpins space exploration and astronomy.
You want me to cry?
Yeah, exactly. And just talk about how, like a lot of people don't realize that the space launch system, for example, is not just a launch system, it's the law, right? It is the
Yeah.
law of the United States. And
I this one we're doing only after I have figured out my funding situation.
yeah, and you're sure that no one can have any problem with us talking about politics. Galactic filaments, Sloan Great Wall, Boss Great Wall. I think we've talked about
Yeah.
cosmic voids. We actually talked about them with Paul Sutter, which was fun.
Yeah. We did that a while ago.
Um, So people are talking about electric cars, silent electric cars. I just bought one.
I'm sure that's how I'm going to someday die.
Yeah,
I'm going
yeah,
to be out bike riding. I'm
yep.
not going to notice one, and it's going to kill me.
I got a Nissan Leaf. I traded in uh, my Honda Civic for a Nissan Leaf. I wanted an electric car since I was a child, and I finally pulled the trigger and got one. So it's awesome. I love it.
I have a 1997 Jeep Wrangler and drove 2,000
Great.
miles last year.
Yeah. But anyway, I saved the planet. You're all welcome. Global warming is problem has been fixed. So maybe we should worry about some other issues. I think that's how it works. I
I
am
wish.
offsetting everyone's emissions. All right, well, hit us with some questions. Someone I saw put in the question. So Richard Hayes asked, could a spacecraft have lots and lots of ion engines to speed them up?
It's you're still going to have the increase in mass with every drive that you're adding because it does weigh something to add the drives.
Yeah,
So you're better off just accelerating for a longer period of time and adding fuel instead of adding drives.
right. So if you needed to, you could and this is if you had some specific mission where you really needed more thrust, then you could add more drives and eventually hit something, a double, triple, 10 times the thrust. But
Yeah,
that's
it
wasted
just
mass on
takes you a while.
drives. Yeah.
Yeah.
Uh,
Yeah.
hit us with some questions.
I'm turning my heater back on.
And your fish tank.
Yeah, the fish will be fine a little bit longer than I will.
The car. So the electric car, it is quiet driving forwards. It does make a beep 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 sound like a truck backing up when I go backwards, and I guess that's the concession that they put into it. But no, it is. It's pretty quiet inside.
Yeah, which
Um,
is excellent. But as a bike rider, I live in terror of electric cars.
they just tore up a big chunk of our road in the middle of the city and replaced it with a bunch of bike lanes.
Mm,
So it's a
excellent.
you get like five whole blocks of easy bike riding. That's it.
It's
Astro
all you're
YYZ
allowed.
is asking, why did Dawn die? Lack of xenon? Could it be refilled if we get a refilling mission to series? Why is Dawn dying?
So with Dawn, I read and I don't remember. It ran out of one of the things that it needs to keep its communications and everything else still going. Sorry, let me Google that one for you.
Used all its hydrazine.
Okay.
So the hydrazine um, is a thruster they use for maneuvering,
And it keeps the solar panels aligned.
and so even though it had the ion engine as its main form of thrust, it still was using hydrazine thrusters to reorient itself, and it ran out of that. Um, William Mitchell's asking, what defines a galaxy?
Um, so this is one of those things that is harder than it should be because globular clusters. In general, a galaxy is defined as a group of stars and gas that have evolved at a variety of times. But then, of course, you have the exceptions of the smallest dwarf spheroidal galaxies. They have a dark matter halo, which is where the globular clusters seem to be exempted, and they follow a series of specific morphological laws that relate the rate at which these stars are orbiting to the total mass of the system. For the spheroid of the system, um, there's a whole bunch of fundamental plane things that galaxies conform to. And then they also have the King law that describes how their mass falls off as a distance away from the center. It's very generalized. We keep learning new galaxies, find new ways to be trickstery. But in general, it's the a tangle of stars and gas that are gravitationally bound together, that fall off at great distance to zero, and had multiple epochs of star formation, with the exemption of the smallest dwarf spheroidal galaxies that would rather behave like a globular cluster.
Um, Duncan Sargent asks, so can you accelerate an ion engine spacecraft with a conventional rocket first to get it going for a few minutes and then jettison that and just go with its ion engine once it already has some speed?
That's what the Dawn mission essentially did.
That's what they all do. Yeah.
Yeah.
Yeah, so you use a conventional rocket to get out of the Earth's stupid gravity well, and then you use the ion engine once you're not worried that thing is going to fall back down and smack into the planet. From that point on, it's ion engines.
Exactly.
LKSSBBWS09 says, any news about solid state ion engines the size of postage stamps that are stuck on via van der Waals force effects? No, but that sounds
No,
super cool.
that is not a thing, though.
Which part? A solid state
The
ion engine?
getting them the size of a postage stamp.
Right. And then having them stuck on with van der Waals force. The van der Waals force, that
Yeah.
is the gecko
Yeah.
fingers, right? And so you can imagine them, but that would be cool having like a little ion thruster that you could just attach to anything and it would just start thrusting. But no. And Zapfan is saying that Dawn used hydrazine for maneuvering. It still has xenon, but it can't maneuver with its 3 ion engines, especially since it lost, wait for it, reaction wheels. I've been learning a ton about reaction wheels. So.
Do people like now send you reaction wheel literature because you talk
Yes,
about them so
yes,
much?
yes. People draw. Someone mocked up a spacecraft with like 50 reaction wheels on board.
And what was the consequence of that?
Well, the mass, of course, right? Yeah. So, no, but I always bring this up, and it's interesting to sort of learn like for example the difference between reaction wheels and gyroscopes.
Mm-hmm.
So this was I was using those terms interchangeably, and they're
Mm.
not. The reaction wheels are used for turning the spacecraft. Gyroscopes are used for keeping the spacecraft stable while it's pointing at some object. So Hubble, for example, it can have its reaction wheels go. If its reaction wheels go down, then it can't point itself. If its gyroscopes go down, then it just takes bad pictures.
Yeah.
Maybe that's an episode. Reaction wheels.
Okay.
Um, but I found that great. George, and now I understand George Edgerog. It's just George again, but the letters are all scrambled up. How far from the sun can ion drives work from the sun due to solar power? So how far can you seriously get an ion engine to work?
It depends on how good your batteries are, because you can use solar power, and I'm going to sneeze at some point. You can use solar power to charge batteries.
Thanks, John. I
Sorry
was able
about
to
that.
see that link, even though Nightbot hid it.
So you can use solar power to charge up batteries and then discharge those batteries while running an ion engine. So it depends on, do you want continual acceleration? Do you need it only to have a delta V? If you can have extraordinarily efficient batteries and you only are worried about changing your velocity periodically, then low solar power slows you down on what you can do, but as long as you can charge your batteries, you're still fine.
So I found the research article. So John posted the research article, which was great, about these micro thrusters, and it's a legit thing. So MIT has created some micro thrusters, penny-sized rocket thrusters that can be used on CubeSats.
Okay, I lied.
Yeah,
I
no,
didn't mean to lie.
no, it's fine. It's fine. So it looks like a computer chip with a bunch of little microscopic blades coming out of it, and the spiky tips create a puff of charged particles that can propel the satellite forward. So they're so small you can put several on a vehicle, and you
Does
could
it get power from
solar.
external to itself?
Yeah, yeah, it's getting
Okay.
solar power, and I don't know what it's using as a fuel. Um, they don't say what the fuel is.
It wouldn't need fuel if it's simply ionizing things so that they
Yeah,
go
but
away
where's it going to
from it.
get them from? Where's it going to get these things that are ionized?
Ions exist everywhere. That
So
was the
so
original.
right. So the spacecraft maybe can collect them and then and then eject them out and slowly turn itself. So it's we thought that talked about ion engines being a lot of power or being almost no thrust. This is like even a
Nothing.
fraction of a fraction. But again, in space, there is no. Here, I'll put the link in the. People can check this out. Um, yeah, in space, there is no
No
worry
one hears you
about
scream.
there's no friction. So even if it's a tiny little force over time, it's going to do the work. So
And the original pioneers of this thought that it would require vacuum to actually be efficient.
yeah, very cool, awesome. Thank you so much for pointing that one out. All right, more questions. William Vandebeek asks, if a spacecraft can be turned with reaction wheels, can a spacecraft also be propelled forward with reaction wheels?
Yes.
No.
Well, so reaction wheels allows you to rotate in whichever direction you want to rotate, depending on how you have the reaction wheels spinning. So does he mean rotate forward or backwards or move forward and
Move forward, like
backwards?
fly through
Oh, no, no,
space.
no. You can't. No, you can simply change your orientation about your center of mass.
Right. So the whole point with reaction wheels is that you're spinning this wheel and the whole spacecraft turns in the opposite direction because of conservation of momentum.
Yeah.
But to try and move forward through space, spinning the wheels, you're just not going to go anywhere.
Yeah.
You can just change your angle. That's it. Susie is wondering if people want to see a reaction wheels versus gyroscopes T-shirt.
Yes.
That's cool. I love this idea. I don't know if I had this idea about making T-shirts that are like useful in an apocalypse, right? And
Yes.
so you would
Yes.
have on the front of the shirt would have like say how to make like fire making instructions, but it would be upside down on the front of the shirt. And so you could like look down at the shirt and then go, oh right, okay, these are the mushrooms that I can eat. But then the back of the shirt would have the additional information or the same information, but it would be right set up for other people walking around you. And so I figure you could make them like on a construction site or things like that, so people could walk around on the construction site and have all of the various formula that are required or health code requirements or things like that. So anyway, that was my big idea to make
It
millions.
goes well with the like periodic table
Yeah.
and the um oh Maxwell equations, and I had all sorts of shirts as an undergrad I wasn't allowed to wear during tests.
Right, because they're cheating. Um, oh, here we go. So John is saying the bottom of the chip contains a small reservoir of liquid plasma of free-floating ions that is the key to the operation of the device. So now we understand. You've got these tiny little chips, and there's a little reservoir of liquid plasma at the bottom of it that's run by electricity. When you run power through it, the the ions are pulled up to the top of these little spikes and ejected off, puffed out into space, and it gives you a tiny little thrust. That is very cool.
Yeah.
uh, J.I. Pearson says blocking a rotating wheel can propel a vehicle forward. I have tried it on a bike. Yeah. The problem with a bicycle, of course, is you've got the friction of planet Earth that you're working against.
Yeah. Yeah. Having broken my arm in two
Yes,
places.
exactly. I believe that is
I think that was more of a momentum issue of one of the reels stopped rotating and the momentum didn't stop.
right. Yeah. Yeah. So you're not in a closed system. It is a larger system that
Yeah.
forces around you that you're dealing with. You posted a link to this Redbubble. What is that?
So CosmoQuest has a Redbubble that's filled with spacey shirts, and we periodically take the ideas that people come up with during the show, and we're like, Austin, awesome graphic person, can you go make the thing? So there, for instance, is a shirt that's uses it's a parody on the Coca-Cola Classic logo, except it's Planet Pluto Classic because it's not a new planet, but it is a classic planet.
Right. Was once a planet.
Yes.
Send your letters to Pamela, not me. Um, Man, I don't have any more questions.
Okay.
I think
Well,
I think it's time to then wrap things up. Uh, when is the next thing that is happening that you're going to be broadcasting?
I am probably going to be doing some random streaming later today with this ion drive of black holes. If I have time, that's going to be a thing.
You're
I
going
will
to do
be
the math.
painting. Yes, and
That's
I'm going to
awesome.
be painting planets and contemplating planetary atmospheres tomorrow on Twitch. We are back Monday with the daily space. I have finished all of our updated layouts, and I hope to see all of you there at 1 p.m. Eastern, which is 6 p.m. London and 10 a.m. Pacific.
Fantastic. All right. Well, thanks everyone for watching. Thanks as always to the Weekly Space Hangout crew for being our executive producers. Couldn't do this without you. Thanks to Susie Murph. I don't know if Nancy Graziano's kicking around. The rest of the team at CosmoQuest. Uh, and thanks to all the viewers. All right. We'll see all of you next week. Any solar panels? No, I don't have any solar panels yet, but I totally want to. All right. We'll see you all later.